Hi Prof, we are Team 26 and today we'll be talking about our IoT project, which is Emergency Response System for High-Risk Individuals. We have Kayang, myself Timothy, Sherwin, Raymond and Alex. IoT has revolutionized modern life, including healthcare and emergency response systems. Our focus is high-risk individuals living independently who face heightened risk due to medical conditions, emphasizing the urgent need for user-friendly emergency solutions. Our initiative is designing and implementing an emergency response system for high-risk individuals, utilizing IoT technologies to empower vulnerable individuals and also ensuring safety and peace of mind for elderly individuals.
So I'll now talk about what our project is about. So basically our project is about creating a smart home system for high-risk individuals to enhance their health safety at home situations. So some of these features that might support the mission is real-time button alerts and fire button for individuals to alert the caregiver in the event of an emergency. Location tracking to track the location of the individual in the home setting itself. Next is the temperature and humidity monitoring system. Is to monitor and track the environment of the individual. The web server. Web server is basically a application that can help communicate all devices on the smart home system. And lastly, it's the fall detection system, which is to detect a fall if the individual experiences a fall within the home setting itself.
So next, I'll be going through the 6 hardware and software components of our project. So the first one is the M56C Plus, which is the main core device of the project, which is expanded on. So it integrates sensors and communication modules. So for the sensors, we are using the inbuilt sensors of the M56C Plus, which are the accelerometer, speedometer, the geometric sensor, and as for the external sensors, we are using a temperature and humidity sensor to determine the environmental data. Next, we are using algorithms to determine whether the wearer has taken a fall, to monitor the amount of steps that the wearer has taken, as well as environment monitoring in the form of temperature and humidity. Next, we are utilizing Flask, a web framework as our interface, which implements REST API for the web server to communicate with the M56C Plus to provide real-time insights and alerts as well. And as for our main communication protocol between the M56C Plus and the web server, we are using MQTT as our main communication protocol, whereby it is reliable, it consumes low power and bandwidth, and it is highly scalable, which fit the main objectives of the emergency response system. Lastly, we're utilizing geofencing, which allows us to define safe zones and trigger alerts wherever applicable.
To set up, just run a mosquito from your CMD. This is to run the broker for MQTT. Then just run main.py. Next, turn on your M5 device. So it's turning on here. Now turn on the other one. So it's connecting the MQTT broker. So you can see we have connected 2 individuals. So let's see on our webpage. Yeah, so we have Alex and grandma team that is set up. It will automatically subscribe. So any M5 that turns on will be automatically shown in the list of M5 sticks here. To set up, just run a mosquito from your CMD. This is to run the broker for MQTT. Then just run main.py. Next, turn on your M5 device. So it's turning on here. Now turn on the other one. So it's connecting the MQTT broker. So you can see we have connected 2 individuals. So let's see on our webpage. Yeah, so we have Alex and grandma team that is set up. It will automatically subscribe. So any M5 that turns on will be automatically shown in the list of M5 sticks here.
As you can see, after the device is set up, it will display your step counter here, which will be manually updated when you move, as well as automatically regenerated every minute on the server by default. Additionally, you can also manually press the refresh button here to query the M5 Stick C+ for its sensor information, namely the acceleration, step count, longitude, latitude, distance away, as well as the temperature and humidity detected on the M5 Stick C+. Additionally, the M5 Stick C+ will also utilize MQTT for the fault detected, emergency, and alert functions, as you can see on this screen. I will demonstrate the emergency function here by pressing the button to activate the emergency alert, which will light up the MQTT as well as immediately responding on the server here. It can then be reset by pressing and holding the button for 1 second or more, which will deactivate it as well as the light, and the state will also be reflected on the server. As for the alert function, you can see that when I press the activate alert function here, it will activate the M5 Stick C+, and it will be displayed alert here. It can be deactivated using the same method of pressing and holding the button for 1 second. Moving on to the fall detection feature, the MQTT at all times, the M5 Stick C+ at all times will detect a fall should it occur, and it will also be reflected here via MQTT on the server, which can be reset by pressing this button as well. It can also be reset by pressing the emergency function button.
To conclude, we managed to enhance health security of high-risk individuals and relieve the minds of caregivers. Secondly, we also created an integrated IoT system working robustly with one another. And lastly, we also designed this product with user in mind in simulated real-world conditions. Thank you.
We have come to the end of the demo. Thank you very much.